In this video, we're going to extend what we learned about rotations to include the coordinate plane. Recall from the previous video that unless otherwise noted, all of the rotations that we do will always be counterclockwise. Now, just like we saw before in our previous studies, the notation for a rotation is going to be a capital R to represent rotation. The next thing that you see listed will be the center of the rotation. And now that we're working in the coordinate plane, the center of the rotation will usually be listed by an ordered pair. And then the angle, or the number of degrees through which the rotation is going to occur. And again, this whole notion of counterclockwise versus clockwise. Counterclockwise, remember, will be a positive number of degrees, whereas counterclockwise will be a negative number of degrees. All right, so let's go ahead and get down to business and take a look at our first example. It says if we're given point P with coordinates 4, -3, in part A, they're asking us to find point P prime, which is the image of point P, after a rotation using 0, 0, or the origin as our center, and rotating through 180 degrees. Well, you probably guessed that because I'm working in the coordinate grid, the very first thing that I'm going to do is I'm going to go plot and label point P. So point P is living right down here in quadrant 4. Notice I plot the point, label it point P. And at this time now, I want to go ahead and I want to perform my rotation. The rotation is using the origin as the center. And I'm going to rotate 180 degrees. So in other words, 180 degrees would be exactly halfway around the coordinate grid, 360 being a full circle. So if I want to go 180 degrees or halfway around, rotating from something from quadrant 4 is going to take me into quadrant 2. In order to perform this rotation, what I'm going to do is I'm going to take my straight edge, and I'm going to go ahead and I'm going to draw the line that goes through point P and through my center of rotation. And I know that the image is going to have to be an equal distance from the center as point P is. So I'm going to literally, because I'm on the coordinate grid, I'm going to count. In order to get from the center to point P, I count over 4, down 3. Point P prime is going to be up 3 and over 4. So point P prime is going to have coordinates -4, 3. And again, all I did is count 3 down. I counted down 3 over 4, counted up 3 over 4, but in the opposite direction for a rotation of 180 degrees. So again, P prime has coordinates -4, 3. Part B says find point P double prime, the image of point P. So it's important to note here that I'm going back to my original point P. So I'm going to go back to this guy right here without any prime notation. This time, again, I want to use the center as the origin as the center of my rotation, but I want to rotate 90 degrees. Because it's a positive number of degrees, I'm going to be going counterclockwise. So if I think about the gist or a general idea of where this rotation is going to take me, 90 degrees is going to be 1/4 of a rotation, and that's going to take me from quadrant 4 up into quadrant 1. So that's the direction that my rotation is going to go. Here's where I have to pull back a little bit of my knowledge from coordinate geometry in the first unit. I want my rotation to be exactly 90 degrees. In other words, 90 degree angles are going to be formed by perpendicular lines. And in our study of perpendicular lines in the first unit, we learned that lines that are perpendicular in the coordinate plane always have slopes that are negative reciprocals. So again, 90 degrees, I'm thinking perpendicular, I'm thinking negative reciprocal slopes. So if I go look at that first line that I drew, that was the dotted line that contained both P, my starting point, and my center of rotation, it had a slope that was equal to 3/4. The slope of a line that's perpendicular to that, which I'm going to notate by M perpendicular, is going to have slope now -4/3. So if I get out my straight edge here and draw that line that passes through the origin with a slope of -4/3, he would be perpendicular to that original dotted line, forming that 90-degree angle. So again, the negative reciprocal slopes tell me that those lines are perpendicular. So I want to rotate now 90 degrees, and I want my image to be an equal distance away from the center of my rotation. So again, because I'm in the coordinate grid, I'm simply going to count. I went down 3, right 4. So I'm going to have to go up 4 into the right 3. So again, same distance, 3 and 4, but now in such a way that those are perpendicular. And there's my double prime. So P double prime now has coordinates 3, 4. And then the last rotation they want me to do is to find point P triple prime. He too is the image of point P, so it's important to note here that our starting point is still our familiar friend point P here with coordinates 4, -3. This time I'm going to rotate again using the origin as my center, but this time I'm going to rotate through 270 degrees, or in other words, 3/4 of an entire turn. So if I'm starting out down here in quadrant 4, again, just a general idea of where I'm going to end up, I want to go 3/4 of the way around the grid. That's going to put my landing point for point P triple prime somewhere here in quadrant 3. As you might have guessed, that 270 degrees is going to be 3 of those 90-degree angles. So he's going to be on the line opposite from P double prime at 90 degrees. And again, I'm just going to do the counting because point P triple prime is going to have to be the same distance away from the center of my rotation as point P was. So I'm going to go down 4 and over 3. And that gets me to the image of P after a rotation of 270 degrees. So looking at the graph now, the coordinates of point P triple prime are going to be -3, -4. So as you might have expected, now that we're here in the coordinate plane, we're going to be using more counting than measuring because we have the grid with which to do the counting. As always, I'm going to ask you to take a few minutes and reflect upon what you've seen and heard in the video, and then see if you can apply what you've learned to answer the questions on the next page.